This is a doubt clarification video for 11 Advanced, 22nd topic, 35th question. It's about whether Fatima and Aisha live exactly 4,000 feet apart. While on the phone at their homes, Fatima hears thunder out of a window and Aisha hears it 3 seconds later out of hers. If the sound travels 1,100 feet per second, determine the equation of the horizontal hyperbola on which the lightning is located. Now they are asking you to find a hyperbolic equation. So before everything, let's try to understand this. Fatima and Aisha are two people. So I'll just put over here Fatima and Aisha, or it can be interchanged, it's fine. Now what happens is they are living 4,000 feet apart. Okay, and here Aisha hears it 3 seconds later, but whereas Fatima hears the lightning at once, like at the beginning, and Aisha is later on. So what happens is they have told horizontal hyperbola, the lightning is located as a horizontal hyperbola, isn't it? So we must understand that is closer to Fatima than Aisha. Why? Because it's 3 seconds later. So now sound, you might have known sound is about 340 meter per second. But now over here it's in terms of feet. So what happens is sound travels from here. If the sound is produced, it takes time to travel. It travels 1,100 feet per second. So now what is the distance which it took to travel over here? Near Aisha, the hyperbolic thing over here is basically 1100 into 3. Now, what to understand over here? Whenever they give you the two important people, they are the focus points. They are living 4,000 meters apart, so that is C. And then over here, the Fatima hears the sound, the thunder first, and then it takes 3 seconds to go over here, so it is 1,100 times 3, the distance between this hyperbola to the other hyperbola. So usually hyperbolas are in a pair, isn't it? So this is one branch. They have told horizontal hyperbola over here, and this is the next branch. That would be, this one would be 3,300. So this is the vertex. See, the bigger length, always the bigger length is the foci. So now over here you can see this is big, whereas this would be 3,300. That is the vertex. And then we need to find the b value to write it in hyperbola. So all you need to do is you can easily solve the b value. That is, we know c square equals a square plus b square, and you can solve for b square. Okay, I have done one mistake. It is 2c and 2a. Okay, always remember it's from the center, right? The total length. So now you need to first find a, that is half of this. C is half of this, 2000. Substitute and solve. You'll see the method. Over here, whatever I just now told is told. 3 seconds later, so you have to multiply 3 seconds to the speed. So when you're multiplying over here, you get only the distance. So 3 feet per second multiplied by 3 second, second cancels and distance remains. Therefore, it is 3,300 feet farther apart from Aisha than Fatima. What it means is this one, the lightning hyperbola is towards the foci, that is Fatima's. Okay, Aisha will be farther away. So if this is Aisha, that's farther away. Now, all the points that are 3,000 are closer to, this is what is just explained over here. The locus of point means all the set of points. So now when the lightning happens, there'll be a set of points, right? Like a hyperbola that is all closer to Fatima than to Aisha. So this is the branch. Now, yeah, with all this information, you can easily solve it. Now, only the important thing is this multiplication part. And now you know 2a is 3,300. So a will be half of this 1650. A squared can be found out. Now, what about c? It's the same thing. Divide 4,000 by 2, you'll get c. Now, use it in this particular equation to find b squared. Look over here. The formula is generally given as c squared equals a squared plus b squared. Now what do you do over here? Just rearrange and find the value of b. A goes to the other side, subtract it. Whatever answer you find it, write it over here. Now, important thing, they have told horizontal. Horizontal hyperbola means the positive sign will be for x, minus will be for y, and then equal to 1. So this is how we can solve the hyperbola 35th problem.